Assalamu alaikum and good morning, dear students. Welcome back to AM Chemistry, Learn Chemistry with Dr. Poonam. In this video, we are moving beyond MCQs to tackle extended response question from the same unit, Chemistry of Transition Elements, and same past paper, Session 1, 2023-24. So student, please make sure you have your notebooks ready. So just I say, without wasting time, we will start. Let's start. Coming to question number 15, student. Copper is a transition element that can form stable ions with ligands. So our first question is, define the term transition element. This is simple knowledge based question. You need to write down definition as it is. An important thing is that you need to mention keywords. So transition elements are d block element. This is essential keyword which form one or more stable ions with incomplete d orbital. So student, here as we know that transition elements are d block elements because last electron is entered in d orbital, and when they form stable ions, they should have incomplete d orbital. So these are the keywords. So write down definition as it is. If we want to write down any example, we can write down nickel. So atomic number of nickel is 28. We can take any random example. So argon core up to electron 18 and 4s2 3d8. This is a normal electronic configuration of nickel, and nickel after forming 2+ ion, number of electron 26, and electronic configuration will be argon core 4s0 and 3d8. That means students, 3d as a 8 electron, so it has an incomplete d orbital, and this is the reason nickel is d transition element. Now next question number B. Write the electronic configuration of copper using argon core to represent argon core. So students, when we write electronic configuration of copper, we should know atomic number. Atomic number of copper is 29. It's a neutral, so that's why number of electrons are equal to number of protons. So number of electrons are also 29. So when we write electronic configuration, we should keep it in mind, copper is exception to above principle. We will write argon. So argon means up to electron 18. And here student, 3d orbital is filled before 4s orbital, and this is explained on the basis of stability of completely filled d orbital. 3d orbital has 10 electron and 4s has 1 electron. So if I draw box diagram for d orbital, so we can see student, as we know that d orbital has a capacity of 10 electron. So 10 electron means it's a completely filled, and due to this completely filled d orbital, it gains extra stability, and this is the reason copper has electronic configuration 3d10 4s1. This is very important. Copper and chromium are exceptions to above principle. So student, note down this electronic configuration. Question C. If copper ion forms complex ion with 6 water molecules, draw the geometrical shape of this complex ion. Your drawing should clearly show 3-dimensional shape and should include the overall charge on the complex ion. So students, we need to draw geometrical shape of this complex ion. So first we will write a simple formula of complex. So copper is a central metal ion and 6 water molecule. As water is monodentate ligand, because it donates one pair of electron. Charge at the end we will calculate for drawing geometrical shape, but especially three-dimensional. So copper is in center and it has a 6 coordinate octahedral shape because 6 water molecules are arranged around copper. So first two solid lines indicated the bond is in the same flat plane as on the paper. Here water and here water. Next to it, students, dash lines. The dash, whenever we are drawing dash line, that indicates the bond is going away from you, behind the page. So two water molecules are here, and then two solid wedge lines, two bonds. The bond is, this indicates the bond is coming out towards you, like somewhat popping out from the page. And in all cases, students, arrow is pointing towards copper, as water is donating lone pair of electron and water is ligand. Then after, it is very essential to give this square bracket, and here we need to write down charge. So to write down this charge, students, we have to find out overall charge on complex ion. So as it is already given, copper is 2+. To calculate charge on complex, we have a formula. Charge on complex, you can note down formula. Complex ion is equal to charge on central metal plus sum of, or you can write down total sum of charge on ligand, summation of charge on ligand. So it is given copper has a +2 and water is a neutral ligand, so 6 into 0 because 6 water molecules are there, so that means that it will be +2. So total charge on complex ion is +2. You need to write down this charge here, +2. So in this way you need to draw three-dimensional shape including charge on complex ion. I can show you 3D arrangement. This is octahedral arrangement for hexaaqua complex of water, where you can see these two bonds which are in a plane, then two bonds are going away from you and two bonds are coming towards you. So this is the octahedral arrangement. Now then, C has a 3 sub questions. We have finished one. Then sub questions 2. Explain why water molecule is considered as monodentate ligand. So already I explained here, monodentate ligand means which donates one pair of electron. Donates one pair of electron, or you can write down it form one coordinate bond. One water molecule can form one coordinate bond or one dative bond. This is the reason water molecule is considered as monodentate ligand. Now student, question number 3. What would be the coordination number of the complex if 4 of the water molecules were replaced with 2 ethanediol ions? Here we need to understand how replacing ligands affect the coordination number of a complex ion. This question is actually related to ligand substitution reaction. So in detail we will discuss, students, with chemical reaction. So we are starting with a complex ion, hexaaqua complex of copper H2O6 2+. Okay, where here you can easily see copper is surrounded by 6 water molecules. So each water is monodentate ligand. So each water molecule donates one pair of electron to copper, and this gives coordination number 6 because it is forming 6 coordinate bond or dative bond. Now we need to understand about ligand replacement. Now the question says that 4 of the water molecules are replaced with 2 ethanediol ions, C2O4 2-. So we are replacing 4 of water molecule. So directly student write down 4 molecule are coming out. Now then if 2 ethanediol ions are replacing 4 water molecule, so copper C2O4 2 - 2, and if we are removing 4 water molecule, that means that there will be 2 water molecules are still there, and this is our complex ion. So if you will calculate charge, you will get here 2-. Now student, our aim to calculate new coordination number. So here we need to break down these ligands, as well as we need to understand nature of ligand. As we know that water is monodentate ligand, but at the same time ethanediol ion, or it is also called as oxalate ion, that oxalate ion is bidentate ligand. Bidentate ligand means it is donating, one ligand is donating 2 pairs of electrons. So if we have 2 bidentate ligand, here we have 2 ethanediol ion, so 2 into 2, 4. So it is donating 4 pair of ligands. So there will be students 4 coordinate bonds or 4 dative bond. 4 coordinate bonds means 2 ethanediol ions are giving 4 coordinate bond, dative bond. Its coordination number now it's 4, but still we have water molecule. So 2 remaining water molecule, they are monodentate ligand. So 2 water molecule are forming 2 coordinate bonds. So this is equal to 4 plus 2 is equal to 6. So after ligand substitution also coordination number is same. Initially we were having coordination number 6, and after ligand substitution reaction also coordination number will be 6. The reason behind this, student, ethanediol ion is bidentate ligand, and one ligand is donating 2 pairs of electron, and it is forming 4 coordinate bond, and water is also forming 2 coordinate bonds. So this is the reason, student, this coordination number is 6. Coming to question number 16, the complex ion dicyanide dichlorido nickelate ion. No worry about nomenclature, students, because you do not have names. So is a geometrical isomer. Now what is the geometrical shape of this complex ion? And question B is we need to label cis isomer and trans isomer in following drawing. So student, let us start with the 16A. What is the geometrical shape of this complex ion? So already we have shape is given here. So 4 ligands are arranged around the central metal ion in the same plane at 90 degree and forming square. And when we will find this type of arrangement, the geometrical shape is square planar. So this is square planar complex, as 4 ligands are arranged around the corners of central metal. And I can show you, this is the 3-dimensional arrangement of square planar geometry. So 4 ligands, we can see easily 4 ligands are arranged around the central. This is nickel, one can be Cl and one can be chloride ion. Now question number B. Label the cis isomers and trans isomer in the following drawing. So students, to label cis and trans isomers, you should know what is the meaning of cis isomer and what is the meaning of trans isomer. So cis means same and trans means when same groups are on opposite sides. So if we check both given structures, from that structures we can find out that cyanide ion are opposite to each other and here chloride ions are opposite to each other. But at the same time student, when we observe structure B, that time chloride ions and cyanide ions both are opposite to each other but they are along the same side. So when identical groups are positioned on same side, that time the isomer is called as cis isomer, and this is the reason B is cis isomer and opposite will be trans. When same groups are on opposite side, that time it's a trans isomer, and when same groups are on the same side, that time it is cis isomer. So cis, trans and cis. Now which isomer from A and B polar in nature? So to identify student polarity in given molecule, we should understand concept of dipole. So in a very easy way we can understand this concept of dipole. There is a generation of dipole. As if I take a simple example of HCl, so we know that H is electropositive and chloride is electronegative. So this is negatively charged and partial negative and partial, so polarity will shift towards chloride ion. So here also if you see this structure, so when two Cl ions are next to nickel ion and two Cn ions are opposite to chloride ion, so that time here students there will be generation of dipole, as cyanide ions are more electronegative as comparatively chloride ion, so dipole will shift toward cyanide ion, and this is the reason your B structure is polar in nature. Polar means generation of two poles, generation of dipole. When there is a generation of partial negative, it will be partial negative and it will be Cl is also negative charge, but when we say in case of polarity, the cyanide ion is more electronegative as comparatively chloride ion. Then in case of trans isomer, the polarity generated by this cyanide ion is exactly cancelled out by the opposite cyanide ion, because this cyanide ion is also trying to attract pair of electrons, this will also try, so it will cancel out. Same concept is applied to chloride ions, so they are oppositely arranged, so when they are oppositely arranged they will cancel out their polarity, and trans isomer will be non-polar in nature. So student, please, one thing you have to keep it in mind, whenever you will see this type of structure, your cis isomer, you need to find out which is cis isomer, and cis isomer is polar in nature, and here our cis isomer is B. This is the reason B is polar, and trans isomer is non-polar in nature. This is about student question number 16. So here we have finished questions from transition elements, chemistry of transition elements, from session 1 2023-24. In next video we will discuss about our second lesson, that is quantitative kinetics. Thank you very much students for your patient listening.